Good morning, sir. Myself Subhanshu Raj, and I am doing here a term project of environmental engineering on water treatment system for the city of Muzaffarpur under the guidance of Dr. Siva Nagendra, sir. So, firstly, we will look about some intro on my city, Muzaffarpur. Muzaffarpur is a major urban city, and it is the fourth most populous city in Bihar, and it is situated on the banks of the perennial Puri Gandak River, which flows from Someswar Hills of the Himalayas. And the average annual temperature is around 25.3 degrees Celsius, and the average rainfall is around 1271 mm. So the water resources in Muzaffarpur is Buri Gandak River, but most of the people in the city depend on the groundwater for drinking water. The city has also projects like Buri Gandak River, which are used by the state government for the supply of the municipal water across our city. So I chosen that river as the source of water to design the water treatment, as it is located near the center of the city, as you can also see in the map. So the population data collected the population data of past 5 decades, and you can also see here the rate of growth percentage in 1981 is 23.48, and in 1991 25.30, and so on. In 2011 it's 28.14, and incremental increase in 2011 is 2,61,537. So for forecasting the population for 2041, I uses various methods like arithmetic increase method, geometric increase method, incremental increase method, graphical method, and logistic curve method. So by comparing all the methods, geometric method would be the accurate population for 2041. So I am designing the water treatment plant to meet the demand of 95,76,515 people. So Muzaffarpur also developed day by day because it is under the process of becoming to be a smart city. So now comes out to be the water demand. So average per capita water demand is around 145 LPCD, and average daily demand for the city is around 1300 MLD. So I'm doing a lot of calculation here, which you can also see like maximum daily draft, maximum hourly draft, average water demand, means assuming 15% leakage. So the water required for our treatment plants is twice of the average daily demand. So I will design the water treatment plants for Q equals to 2600 MLD. So firstly, for designing the water treatment plant, we should know about the quality of water available in Muzaffarpur. So the parameters I have taken like pH, alkalinity, chlorides, total hardness, calcium, magnesium, BOD, COD, and total dissolved solids as well as dissolved oxygen. So for designing, we have to follow the different process of the water treatment plant like screening and aeration, sedimentation, coagulation and flocculation, filtration, softening, and then disinfection. So firstly we are looking here at screening and aeration. So screening is the first unit operation in a wastewater treatment plant, in which screens are provided to trap the large suspended or float size particles like trees, branches, bushes. So I place the screen at the angle of 45 degree, and I am choosing circular sieve here to minimize the head loss. So aeration is necessary to kill the bacteria, and I choose here the cascade aerators to pump out and to kill the bacteria to some extent, and also to increase the dissolved oxygen to some extent. So right now comes out to be the sedimentation part. So sedimentation is the process of removing the suspended particles that are heavier than the water by allowing them to settle by gravity. So we have mainly four zones like inlet, settling, outlet, and sludge. So the flow rate and retention time were the two major factors which we have to consider when designing the sedimentation tank. So actually the flow is too high, so I have taken five sedimentation tank. I am also defining the characteristics of the each and every tank. You can also see here, and I assume detention time is 3 hours. L by B ratio is 5. So right now comes out to be the coagulation and flocculation part. So mainly colloidal particles present in the water do not settle by gravity and are not removed. So we need to remove by the process of coagulation and flocculation before the filtration process. So this process mainly happen in four steps, as you can also see here, like ionic compression, charge neutralization, sweep coagulation, and the interparticle bridging. So the turbidity of water is around 145 NTU. So alum doses I'm taking here 18 mg per liter, which turns out to be 39 metric ton per day. So for rapid mix tank design, I am assuming around 40 rapid mixers of height 5 meter. And you can also see here I am assuming a lot of things here. The volume comes out to be 45.12 meter cube, and diameter comes out to be 3.4 meter, and the power consumed is around 45.5 kilowatt. So right now comes out to be the flocculation basin design. So I am assuming 25 flocculation basin. It's having three compartments with length 24 meter and the height 5 meter. So for Q equals to 2600 mld, the flow in each basin is 54,150 meter cube. So after doing a lot of calculation, you can also see here breadth comes out to be 18.05 meter and length comes out to be 24 meter, and the power consumed is 158.087 kilowatt. So right now comes to the filtration part. So after coagulation, water is filtered to remove the suspended impurities in water. So there are different types of filtration, like slow sand filter, rapid sand filter, pressure filter, but I chosen here rapid sand filter for the city. So the rapid sand filtration design, I assume 0.5% backwash and 30 minutes for backwash time. So the area of each filter bed would be the 80 meter per square, and the length by breadth will be 2. So for designing the rapid sand filter, I required 234 filters, each having length 12.8 meter and breadth 6.4 meter. And I am also assuming depth of sand will be in the range of 50 to 75 centimeter. So comes out to be the softening part. So softening is done to remove the hardness of the water caused primarily by the presence of bicarbonates and sulfates of calcium and magnesium. So there are various methods for calculating the softening, like lime soda as method, caustic soda method, split method, but I chosen here lime soda method for designing water treatment. So you can also see here, I have taken a table of it. I actually taken the table from the quality of water, which I already presented in slide number 7. So right now I am balancing the cationic and anionic proportions, which comes out to be 2.76 and 3.24 respectively. So the for the calculation of lime and soda requirements, so the lime requirements comes out to be 3,41,510 kg per day, and the soda as required is around 194 metric ton per day. So right now comes out to be the disinfection part. So actually this is the last and the final treatment system, which finally making the water both potable and the wholesome. So water also contains various pathogens that may lead to some chronic diseases to mankind. So I will add here chlorine as a disinfectant for this issue. So the chlorine requirement will be around 1.5 mg per liter. So the chlorine consumed out to be 390 kg per day, and I'm assuming here bleaching powder with 35% available chlorine. So the bleaching powder required comes out to be 1114 kg per day. Okay, so right now comes out to be the summary and conclusion part. As I already said that the city is estimated to have around 9.5 million population in 2041. So accordingly, the city will have about 2600 MLD. So hence, as an attempt to meet the city's needs, I can design the water and sewage treatment plants, and are planned and are illustrated with design specifications. So the learning outcomes from this course to integration of knowledge of various fields like environmental, biological, chemical, and civil engineering. So I also learned that how to get various population from various forecasting methods, and I finally understood the importance of treating wastewater in near future, as the water requirement is growing significantly, contrasting the depletion in water resources. So we should save the water as much we can. So right now comes out to be the reference here. So I am using population data for Muzaffarpur Wikipedia and photos from Google and Class Slides is so much helpful to doing this project, and I'm also assuming a book of environmental engineering. Thank you so much to watching this PPT, and I really enjoy this course till right now. Thank you so much.